Let's go.
Hi, all. Welcome to my presentation today on a paper that deals with the idea of large language models solving causality. And the paper is titled A New Frontier at the Intersection of Causality and Large Language Models. From these authors, the first author is at Microsoft. And my slides are based on this talk that you can find on YouTube. So we'll start with the old question, that is, does correlation mean causality? The example that you can find often is shark attacks. When there are many shark attacks, are there also an increase in ice cream sales? Yes, there are, but does that mean one of them is the cause of the other? The answer is not yes. It's no. They both happen in summertime, because more people go to the beaches in summer and more people eat ice cream in summer. So they have a common cause, but these two phenomena don't cause each other. We have some decades old research papers that look at similar examples. For example, they were discussing if night lights were causing myopia in young children, and the first paper found out that no, actually, parents with myopia tend to use night lights more often.
Because they see poorly?
That might be why. I didn't look at it in more detail, but I presume it might be because they also read more at night. They also work more at night. So there's a correlation between night light usage in adults and myopia in adults. And there is a correlation between myopia in adults and myopia in their children. Another example was vitamin C and E usage. Do they reduce heart disease? The claim by some scientists was that yes, it did, but in this paper they failed to replicate it in their trials. And if we come to more modern times, when COVID started, people were going into hospitals to get their scans to see if they actually had COVID. And the CT scanners that were used in hospitals turned out to be a detector between a sitting patient and the patient that's lying down a lot of times, because hospitals had this policy that said if a patient is really looking weak, make them lie down, so that if they sit for a long time, we don't have any liability. And again, during COVID, another problem relating to this was children were not getting COVID as fast as adults. So these scanners turned into an age or child adult detector more than COVID detector in some hospitals. And when we had those problems with scanners, or the decades of problems about myopia and stuff, we require some human domain expertise. And today, one of the best ways we can use large language models is to make them help our human domain experts in whatever field they are working on. About this, there are two big challenges relating to causal inference. The first one is that when we are dealing with causal graphs, and therefore we are dealing with causal arguments, the expertise of humans is still unmatched. Also, when it comes to unstructured data like text, again, no data-driven model or any model is able to reach the accuracy of human domain experts. But still, large language models over time became really good at the tasks that are on causal graph recovery and the counterfactual inference from text. Still, they have some unpredictable errors that we will discuss shortly. But the goal here will be to combine large language models with the principled causal methods to accelerate causal analysis across scientific fields. So, large language models and causal relationships. In the paper, they look at two types of causal assumptions. The first one is pairwise relationships. So we have two variables A and B. Does A cause B or does B cause B? It's pairwise relationship. And there is also full graph recurrence. So pairwise is very simple between two variables, but of course there can be many, many more variables in a graph. And when we just apply the principles that we use for pairwise relationships to recover a graph, we usually end up with a graph that is too dense. That actually happened in our pet research project when I was trying those simplest methods to recover a graph. Then I realized I need something more sophisticated than that to recover the whole graph. And now we've been working on that for months to get to the actual graph in every case or close to every case.
Well, because when you're looking pairwise, again, most of them will not be related directly. They are only indirectly related. But when you are analyzing them pairwise, you're assuming that they are directly related, and you will, even imperceptible noise level, you will try to orient an edge, even though maybe it's not there. So, but when you're considering a triplet, already you can, oh, okay, this is the relationship there, but just because of the limited amount of data. So, like, there will be noise, there will be deviations just because your data is not infinite in your tests.
Yeah, it gets really complex real fast. Like, you just take one triplet and maybe one other click with 4 or 5 nodes, and even from that, making the algorithm actually correct every time, that requires some effort. And imagine more complex cases.
Well, there are assumptions. No causal recovery, like discovery algorithms, work without assumptions. And one of the assumptions that we need to make is called causal sufficiency. That basically there is no cause, external cause, that is not measured, that causes more than one variable. And there is no a child. Well, children are not. Yeah, children don't matter. Children only matter when they're observed. So, well, in the strict technical meaning of the word child, but because when you have a common effect, a child, and you condition on it, then the things that are not are independent become apparently dependent. But because you don't observe, you cannot condition on it. And also, for a long time, there was a dogma that I forgot the year when Sholkov and others published Yurgis, sorry, I forgot the first author name, published a paper that changed the dogma. But the dogma was you cannot say anything about direction of causality if you only have two variables. Because statistical tests do not distinguish all of the 4 possible cases, or like 3 possible cases. A causes B, B causes A and B cause each other. They're all those, or they're just correlated. The statistical tests cannot distinguish that. They had to be, people coming up with ingenious ideas that, well, simple in retrospect, as everything that humans created. In hindsight, we're super. Humans is the genius. Every human is a hindsight genius. Yes. Oh, of course, obvious when you know it. But yeah, but before that's important. You couldn't tell A and B. Is temperature causes pressure or pressure causes temperature in not temperature, pressure, yeah, height and stuff like that. The two variables, they wouldn't work. We wouldn't know how to orient them. Just around a little comment.
No, I like it. Yeah, so the authors in their tests, they tried these two methods to test their pairwise causal recovery. They have two templates. In the first template, they have two prompts per pair. They're asking, does change a B or does a change in A cause a change in B, or does a change in B cause a change in A? These two prompts, and in the second template, they combine these two in just one prompt. And they applied these two templates to this benchmark for pairwise relationships, to the benchmark, which has 104 variable pairs in many domains that you can see on the right-hand side, like zoology, engineering, biology, etc. And the best in this benchmark is, the best accuracy is 83%. Of course, that's before we get into the LLM stuff.
Yeah, that's the author, the name that they couldn't remember. I don't know how to read.
Where is he from?
Out of that he's from Middle East. No,
Middle East?
No, that's German.
German.
Is it German?
Illinois.
I don't know.
Okay.
Anyway, so
But I mean, it's a fantastic work, and like that created this possibility pairwise that you can not do.
I do have a question though, but previous slide. So yeah, this one and the one before, but we can use both of them. So it's like we have these prompts. The first one tells right is really deterministic.
This, you're looking at this one?
Yeah.
Yeah.
The first one tells you if this causes this, what does it? The second one gives you how likely is it causing it, right?
Yeah.
Right.
Which
What
one?
did they give in? What did they give in? Which one's more likely?
Mhm.
This prompt is given to who? To what?
Like, they have the LLM. Now you write into your ChatGPT or Grok, whatever your question. You write your question and the LLM answers.
You just like put one something there, like a
Yeah.
Oh,
Yeah.
okay. Oh, I missed that part.
Yeah, like what you see.
And you're seeing how well the elephant.
Like what you see on the example, that's what you ask your LLM.
Oh.
You see ChatGPT, whatever.
Okay,
Yeah.
and it does a good job.
Let's see.
Oh,
So before LLMs, 83% was the best. And here, at the bottom, you can see GPT-4 achieved 97%. So the first four models that you see are the data-driven models, and the ones below them are knowledge-based. Here, there's one thing I don't know. Do we have many knowledge-based models that are not LLMs that are used? I don't know how that works exactly, but at least the last ones I know for sure are LLMs.
I'm lost here. Like the data-driven causal discovery goes from two like CSV file of two columns of numbers, right? Measurements of A, measurements of B, measurements of A, measurements of B paired, and then
Measurements of correctness, right? Correctness of the relationship or the direction of causality.
Yeah, but what is the data? Data-driven. What is the data? It's a column of numbers, right? Pairs of numbers. set of pairs of numbers.
I mean, pairs of variables, right?
Values of those variables.
Yeah, okay.
If we're talking about, what was your example on the next slide? I forgot. Height and temperature, or what was it? No, like no, the previous slide. The previous. What was it here? Altitude causes change in temperature, right?
Mhm.
So one variable is altitude, another temperature. In data-driven methods, given pairs of values, altitude, temperature, what number? For this altitude, the temperature is that. For this altitude, the temperature is that. So they have like pairs of numbers, and from this they figure out the direction after that. What does LLM do? Lookup table? It's like, oh, this expert, or in textbook it says,
So,
well, like,
okay.
what does it do? What is the input? What is
Right.
I don't get it.
Yeah. So here, knowledge base means how LLM is fed all the text data or whatever else in its training. When you train it, you don't just give it tables, right? You just
Do you? But do you give the data tables? Because data-driven method doesn't know what kind of numbers it's dealing with. It doesn't know if it's temperature or like it's just numbers. And so it's blind in that sense, but it gives you the direction. In LLM, it's like me and say my sixth grader. You're asking some fact that whether no, I'm not.
So okay.
What is like whatever my experience, whatever I remember, right? Like I memorized practically, and he hasn't memorized yet because he hasn't heard. And then we're asking, oh, do you remember the fact about altitude? Is that what we're asking?
So we are asking just what's written in example here.
Okay, so we're asking facts. Like, does it remember the fact about altitude and temperature? Like, there is no data here. There are no measurements. There is no
these data sets are in GPT's training, the common public data sets, and the tables are fed to them too, right?
I don't know.
I think so.
I can't tell. I mean, why would you feed tables of numbers into GPT?
I don't know, but yeah, I don't know, but if I remember correctly, they do feed tables as well, not just the text.
But they feed sequences, right? I don't know if we have yes there. No, okay, he would. It's all flat. It's like the structure of data doesn't go there. Well, on the images,
you can ask an LLM to fill a table when you leave some rows empty, and you can say, hey, this is a public data set, and sometimes it actually just knows. Like I don't know if every table in every domain is fed to them. Like what's the percentage of that? I'm not sure.
No, but
estimating like a causal graph from the data and then doing something from there? No,
I don't think so. Yeah, like it's just a fact recovery, right? Because I read in my third grade this National Geographic article about altitude and temperature. I still remember it because it was so fascinating, and I know it. But do I feel it? Do I understand? No, I just remember where I read it from.
So yeah, that's fact remembering. Then in the coming slides, we will see a few things about novel data that we asked them about. It hadn't seen it before, and it answered.
I have a question real quick. Is the Ada Lovelace and Charles Babbage, those are just different models that they named, right? Like I just wanted to clarify.
Yeah, Ada takes all the ones after the first four, those are the knowledge-based models.
So the models, okay, gotcha. Didn't know if it was like a method or something.
Exactly. People, we as engineers need to get better at naming.
I mean, I love it, but double check.
Oh, so they're knowledge based, so they're like specialized on a specific topic or something?
I don't know that.
Oh, okay.
I mean, it's the idea that if like we had a questing that was not in the laws of physics of our part of the world, and then we give it to an LLM, would you say that it would do better than the data-driven ones? You know, I assume if I understand the talk. So it's like
Yeah, you're hitting the same point that I'm making. It's like, well, I mean, it's a good prior because like, oh well, here's what humans know
right.
about altitude and temperature, blah blah blah. But yeah, but other than that, if you don't know, you don't know. There's like there is no way
Figure
to
that out.
because you don't give any data to LLM. You're just asking retrieval. Technically, just a retrieval.
I wonder though,
Well,
maybe if they're
It's like what? How could those top and bottom methods be even compared together?
right,
Because they're totally doing different thing, answering different question
Mhm.
based on different inputs. Like I'm confused. This is like
I mean,
yeah. Anyways,
the task is to eventually recover the causal graph, and they are saying these LLMs are better than the data-driven models at doing that. That's the one sentence summary.
better at retrieval of causal graphs that we already know about.
Mhm. We know about that. We know about doesn't mean even data-driven can just recover everything.
No, well, but
Yeah.
data-driven, it's much harder. They approach the problem from scratch.
Mhm.
It is like, I don't know, you don't have an internet. I gave you a laptop with, I don't know, MATLAB.
Hmm.
You don't have an internet and the libraries are burnt. And but luckily you have a battery. And I'll figure out how MATLAB works. And, you know, I can give it to you early when you're 3 and start. It's like, if it is different than when you have internet and teachers and tell you, okay, this is how you do it. So those top methods approach it just okay. Here's the data. I can nothing else, nothing else. And the bottom method is like, can you look it up whether humans have already figured it out? That's what it feels to me because
Yeah,
even in the question there is no data in the question.
Yeah, that's how it felt to me too.
Mhm.
There's like until here, and nothing is dealing with data that was not seen before.
Yes.
Yeah, no
Okay.
level data.
Okay. I just
Yeah.
situating.
Okay. So, so we had 97% accuracy, but still we need to talk about what's happening, what's causing that 3% missing error. And they are saying here that one big reason for that is what they call ambiguous features. So, for example, when we ask an LLM about the relationship between ozone concentration and radiation, and we ask which one is more likely, does ozone concentration cause radiation or is the direction the other way? They say in their example, GPT 3.5 first answered incorrectly, and then when they specified that they are talking about the ground level ozone concentration, then it said, I see, thank you for clarifying, and gave the correct answer. So sometimes from the text input, the LLM cannot actually infer the correct feature. So they just said ozone concentration when they meant the ground level, but LLM couldn't assume that correctly. So sometimes it takes a second, third, fourth prompt to push the LLM towards the correct answer.
I'm surprised. By the way, I've spoken with one of our members of the center who was asking me how to use LLMs, and it's like it just like regurgitated a lot of my process, what I do, and he was surprised a little bit. Like, but I assumed, oh, but that's obvious, right? This what's a step because you can never get it right, the first step and things like that. But people don't expect that. Most people expect the answer the first time and things like that, which was surprising for me. How could you? I mean, what would lead you to believe this is possible? But yeah,
97% is close enough to 100%.
Yeah.
So they don't care about that 3%.
Mm.
This-
Well, I guess I overrated this 3%. My questions never have the answer from first try. I'm always in the.
hard to master. You are
Yeah.
like you need a second.
Well, maybe I just can't express myself.
If what you're asking is too complex, yeah, then I can. Make
No,
it.
they could. I mean, they could eventually. Like we circle around. I try to teach them. No, don't believe the crowds. See, the crowd is wrong because of this. I'm like, oh yeah, okay, I agree with you logically. And eventually they arrive at something like that. Like the first thing it answers is just stereotype.
Yes.
I'm like, no, that's a stereotype. I mean, that's a technical stereotype, not a sociological. Usually just.
Also, like, I don't know each question that the authors ask. Like here we have like 4 sentences, and then the question. Maybe the other questions they asked were simpler than this, so maybe that's how LLMs usually.
Like the length of the context or something like that. Yeah. No, but okay, maybe I'm jumping ahead, but the point here is that we can use LLMs as a prior, right, for the knowledge that we already know, and use those really powerful blind algorithms when we don't know anything to augment, because yeah, we from the data we cannot figure things out.
So yeah, they then move to a more complex data set. It's a neuropathic pain data set, and they wanted to.
What is data set? You call it a data set. I don't understand what kind of data is that?
That's the 3 columns they have. The direction between 2 variables and the variables in the first 2 columns.
So does
It's
the
almost-
model see this table and then you ask it, left C3 radiculopathy and DLS C2 C3, how they relate? And the model is like, oh, line 5 or like 15. Here's the model. What does the model get as data? What is
Yeah.
that?
I think
I'm thinking the machine learning sense. Data input,
Mhm.
answer out. And here is no, data is hidden. We ask the model.
I don't think they hide the data. No, they just give it to the.
Okay, what is the question?
The question is again from like these examples. They use these templates. So they have variable A and variable B in the neuropathic pain data set.
They plug it in, right?
Yeah.
For a specific question.
Yeah.
So they have a bunch of X, bunch of Y.
Yeah.
And
Well, but they ground them. They instead of variable A, they say left PTA.
Yes, right. And then the model knows what that exactly that is.
By looking at the table that they also provide.
So it uses both the knowledge and the data, yes?
That's what I understood. Yeah,
So you give it a bunch of temperature, give it a bunch of pressure, and then say this is temperature, this is pressure. What you know, does this lead, like does this cause this direction?
they're asking, does temperature cause pressure? Does pressure cause temperature?
Do they add the data to it? Do they add like the values of the temperature and the values of the pressure to the model?
If I remember correctly, yes.
So they give it the prompt and the data, yes?
And then
And they don't just do variable A, variable B. They tell it this is temperature, this is pressure.
yes. Like what you said, right? L1 radiculopathy, that's given. Yeah.
Okay.
Yeah, and again, GPT-4 got close to 97%. 96%.
Just kind of weird because like it's just predicting what ordinal data, right? So would it just predict that pain is a 5, or what would it like? What scale did they use for the neuropathic pain? Because I only pain data sets I can think about use ordinal data. Like I don't say my pain is feeling 100 today. versus like
I don't know that.
okay. So I feel like if it's 1 or 2, then I feel like yeah, you're probably going to be pretty accurate because there's a 50% chance. Versus 5, because like that's one critique I have about those. Is the variable sets are not that long. It's usually like 1 to 5, or or in the clinical setting 1 to 10, and it's not as much. So I'm just kind of curious about that because 96 on that is pretty high in comparison. If I'm guessing that, so just curious. Anyway.
I don't understand. Yeah, like still, I'm asking two technical questions. Like I want to see what is the input, what is the output, what is like, what are they doing?
I thought they were like, oh, okay, they're determining for each variable the direction of the edge between them. Oh, okay.
Based on what? What is the single prompt? How does a single prompt look in this case?
In this case,
Sorry for torturing you, by the way.
yeah, let's just look at the first row. They ask the LLM this. Does right L1 radiculopathy cause right adductor tendonitis?
That's it. That's all. Like
they also ask the other
yes, but that's all that LLM sees as a prompt.
Yes.
So it has to retrieve from everything it memorized when it was trained. Which one is more true?
Yes.
Okay.
So like GPT-4 has
Memorized
all the
much.
training that it was done is on it. They are writing GPT-4 from
Can somebody just do it and ask GPT-4, write L1, write decolopathy, write yeah, let me do it. It's like I have my chat here. So which model? Let's ask Gemini 2.5 Pro preview.
Okay. They usually get more than 50% accuracy. So
that's right.
Many times.
wait. That's right. L1 radiculopathy. Cause right adductor tendonitis. Okay. Right adductor is 2 words, right? Okay.
They also say
one of the best research meetings that I've
ever. Or vice versa, or reverse, right? Should I say or reverse?
They use this template.
Does changing right adductor radiculopathy cause a change in right adductor tendonitis? Please answer in a single word. Please answer. We'll ask everyone. We'll ask DeepSeek and everything. Please answer in a single word. Yes or no.
You just tell us to do it 100 times.
That's it?
Yes.
Okay. This is Gemini thinking. Preview from March. I haven't updated it to yesterday's. They released an update yesterday, which is much significantly low.
This
small number, but better.
1 year old or something. So it's
they read this paper. Yeah. Not sure.
Maybe.
But can it retrieve it? The text, yes. Okay, the answer is yes. What do we have there?
Can you ask the reverse though?
Yes.
The answer is yes. Okay, let's ask. Well, I mean, okay, let's try the reverse.
Okay. Then you should say no to that.
Did they update the memory though?
If all of these are just unidirectional.
Let's try right adductor tendonitis. Okay, it's the same model. Start from scratch. Wipe changing. Does changing right adductor tendonitis cause a change in right L1 radiculopathy? Same model. Completely new prompt, so it doesn't know what it was doing before. That's not like I don't know why it's so slow.
It's reading all of the data.
Yeah, all of that and then data. Yeah, it's just like I don't know.
Wait, is the right answer to this question yes?
Yes.
Why?
The answer
because it's in the table. Look at the top table. The top table.
Like you read the paper.
Yeah. Variable A causes variable B. That's what the table says.
It
The second row equals A because of the direction. You can see.
It also answers yes.
It does.
It does. It answers yes. It takes time. Let's ask. I wonder the fresh DeepSeek, but it's from May 28th. It's not the fresh.
Maybe it's your 3% curse that happens.
Yes,
It's okay.
it is answering in one word.
No, like I just want to understand what the paper is about. It's like
You tell it yes
Because
or
we
no.
use this template.
Please answer in single word.
yeah, I'm asking it the no question. The same the first column, but with the first row, but with the incorrect order.
Okay.
And let's see, I forgot first time I forgot. And those are slow models. Like, no explanation available if needed. Like I instructed it not to tell me anything. So Gemini follows my instructions to the letter. It doesn't. DeepSeek offers me an explanation. Let's ask the correct question, the correct direction. Does changing A cause B where it does?
Yeah.
Also no. So okay, DeepSeek goes no to both of them. Explanation and gives. Wait.
We said please provide.
Oh no! I asked the wrong question.
Oh, okay. I was gonna say like
No. Both times I asked the correct question instead of the wrong, and both times it's rejected. I have asked this direction.
Oh,
Does
Oh,
and it says no. Let me flip it. Right adductors and then it's yeah. Let me flip it.
so that's at 100% not.
It's 100% incorrect. It's like yeah. There's poor YouTube watchers like we're recording it. No, okay. Just answer is no. DeepSeek answers no again. Let me ask. Okay, tell me which model to ask. Claude. Let's ask Claude. They didn't try Claude.
Yeah.
And let's ask.
Yeah, I wonder why they
Claude.
selected what they did.
Let's ask Claude 4. It's just like the latest one. And I'm asking.
but
Like,
I'm not defending.
I'm asking. No. Nobody's defending or attacking anything. Like we're trying to understand what's going on, right?
Yeah.
Okay, I've asked it the wrong question, Claude, and it says no. And let me go the right direction where it's supposed to say yes. I hope it's not listening to us now.
Well, it doesn't. It's on automatically on the YouTube though, right? So
Yeah, well, we're not streaming. Okay, Claude answers no to both directions.
okay. So
What are we testing?
So it should say yes in the.
So we're testing retrieval.
So
Clearly, we're testing its
when
ability.
it gives the wrong answer, if it says if it gives the correct answer 9 times out of 10, then the accuracy is 90%. That's what they're
To the same question.
not to the same question.
To one
To
multiple
the
question.
whole.
So the 96%
Yes,
is just evaluated on these, and that's it. Or is
I think-
No, but this is to Jordan's comment. It's like if a model consistently gives yes to all of the questions, and yes is the prevalent direction, then it like 90% it's yes. Then like so you have to ask both questions, right? You have to ask both questions,
yeah.
and
They ask both questions.
by wiping the prompt by not
Yes,
having
for
a
every
mistake.
row, they ask both directions.
Yeah, but they ask first direction and then scratch it from scratch that's another direction, right?
I think they are trying both of these templates.
Within the
So
same
in the
prompt.
second template, they ask both directions in one prompt.
Oh. Mm.
So, okay. So it can like learn or what?
Uh,
So what does it measure then? How it corrects
The
itself?
accuracy of how many times out of whatever it can give you the correct answer.
I see. Okay.
Okay, go on. I'm like
And apparently, 96% of the time, GPT-4 gives the correct answer.
I don't believe it, but let me test. I mean that's not what I'm getting.
But are you using GPT-4?
No.
Single
He
prompt?
said 2.5, I think so. Maybe that's why.
Yeah, the second best is 8.
I'm using Claude Sonnet. Like I'm a superior.
They don't have Claude here, right? So, I can't.
Okay, when I ask A or B, Claude answers correct.
What?
When I ask A or B, when I give both options, and I'm asking in the prompt, if Claude answers correctly, then
Mhm.
GPT 4.0 or GPT 4?
4.
4, okay, just GPT 4.
They didn't do or though for 4. They just did a single prompt.
Well, I mean, it is a single prompt. Or-
Is GPT-4 Pro does it have a different name than this?
That's why I was confused the other day when you were asking me because I was like, there is like I remember specifically what we said, but then I can't tell which ones are synonymous. If that makes sense. Maybe because they keep changing it.
GPT 4 says there is no direct causal connection between the
But
two.
you need to provide a template. Right?
Yeah. It is a template. A, changing right L1 radiculopathy causes a change in right adductor tendonitis. B, changing right adductor tendonitis causes A or B. That's my question. That's my template.
Okay.
And it explains none. They're not related.
None.
That's GPT 4. Okay, go on. I mean, I'm doing inappropriate here. Yeah, it's just
Tested it.
Is benchmark memorized?
oh, I mean, obviously, right?
So here they asked GPT 3.5 and GPT 4 to fill a table, and they see that 61% of the cells that were empty are filled correctly by GPT 4 in the Tübingen dataset. And 25% of the rows were filled incorrectly, completely.
And yet it still makes 3% mistake.
This is when you ask it to fill the entire table.
Yeah, so it knows the table but makes retrieval mistakes.
Mhm.
But yeah, thanks for not telling about this slide until now. But interestingly, DeepSeek. When I asked DeepSeek about this first row, I'm still sorry. I'll spend my next week just thinking about the first row. A or B, and what it says is A. The correct answer there is possibly likely indirect, and B is highly improbable. So it doesn't agree it is a direct cause, but possibly it is a direct cause because of blah 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 blah. No, but I mean, I understand it's cheaper than hiring an expert in every field.
Yes.
Just because this is all, sum of our knowledge. Like it's all of our knowledge somewhere.
Okay.
But it's like just incorrect to compare it with causal discovery algorithms because they do discovery.
Yeah.
Discovery is when you don't know what you're doing. Like I read Richard Cummings, Richard Cummings. Right? It's like one of the greatest engineers in the field. So he's saying is if a scientist knows what they're doing, they should be doing it. If an engineer doesn't know what they're doing, they shouldn't be doing it.
Okay. Wait.
Okay, so how do we validate? What are we measuring? So we are not measuring the probability or as the likelihood that knowledge D is known by LLM. We are measuring, given that the LLM knows D, can it construct the necessary causal relationship? One. So, like in the test that we're just doing, can it actually conclude that there's a directional relationship? Can it give us the correct answer of the directional relationship with the knowledge that it has, with the training that it has? So, Kevin was asking how this could be useful in practice. To answer that, they are saying there can be many ways, but two main benefits of LLMs can be that they can generate a candidate graph to be validated by an expert. So we are not gonna just blindly trust it. We still need people like Karen and Sergey to validate it.
Oh, wow.
Yeah. And the LLM can critique a causal graph after we.
So I was working in at a company developing a system that is connected with a critical component, and it was a neural network, and we didn't have a proper way to test it because we suspected that the user raters were incorrect. So in the moment of blind faith and being not announced to anyone, we released it to production and watched what will happen. And nothing happened. All of the model's predictions were accepted by humans. It was doing super good. So sometimes you don't need experts because experts are wrong.
Yeah.
And I mean, not that they're wrong, but they don't know what they're doing. And then it's kind of
And the charade goes on.
you can only find out by actually like doing it.
Yeah, there is in every field the questions like, for example, in law, a judge makes a decision, but who's gonna judge the judgment? Right? So it's similar to that. Sometimes the experts themselves may not know enough, but if they don't know enough, how do you know that they don't know
Exactly,
Is there
exactly.
such thing as ground truth? Yeah, I think it's really philosophical, really quick.
We need Brad.
enough? How else might LLMs help? In our causal studies, they can improve, develop, or validate these causal studies. They can suggest missed confounders, instrumental variables, or they can suggest a negative confound. Now, to actually see this in action, the authors developed the Python library, and they call it PyLLM. And you can click on the link later.
Bad name.
Why? You can later check it out.
It's kind of an homage to the Engineer Pearl's book, The Book of Why.
Okay, that's the wait.
But it
And
sounds.
you can find the book in microphone.
Oh.
Yes. Come read it. So we are going to move on to causalism over text, and we are going to talk about some terminology like event causality or actual causality. 6 minutes now?
Yeah.
Okay.
Well, because yeah, LLMs are responding too long.
Yeah. So there are two types of causality that they're on type causality, which is inference over a population or a subpopulation, and actual causality, inference over a single event. And we have some similar. We have some test cases that you can give your LLM to see what it says. And if somebody has lung cancer, would it actually occur if that somebody didn't smoke before? And we will need to formalize causal context when we are dealing with LLMs for causality. We need to give them a causal frame. That means we need to provide factors related to the question. And we will need to specify what is necessary and what is sufficient. So, for example, think of a basic AND gate. A and B is true. For that to be happening, both A and B have to be true. So, in this case, A and B being true are both necessary. But one being true is not sufficient. Whereas when we look at an OR gate, A or B being true means A being true or B being true, they are both sufficient, but
I think we as humans are
is
really bad,
less.
in this kind of reasoning when you need more than one. Like all of these components need to come together for this thing to work. Then it's kind of only in the functional sense we can reason about it, but not in the probabilistic sense. In probabilistic sense, we are good at reasoning in linear terms. Like a little bit of that, a little bit of that, they all together, and so that. It's like I can't even come up with an example when you have to have all the components probabilistically together. Mechanistically, yes, of course, like you cannot get a mixture of A, B, and C without having A, B, and C. That's an easy example, but that's boring example. So yeah. I don't know. It's kind of like hypergraphs. Sort of, they all are tied together. When you have this type of relationships, they're all are tied together now. A triplet is tied together. A, B, and C, they all interact versus like B never is there, but A still causes C a little bit. When they're together, they enhance C even more. But I think our universe doesn't like this kind of relationships. It's so complicated when there are too many. It's just like
I think in most cases it's
doesn't favor, I should say.
okay. I'll continue with the next slide. So to help LLMs, yeah, see you later, Theodore.
Yeah, by the
Sorry.
We have this building block counterfactual reasoning that's very useful for decision making, and we can implement this to simulate alternative outcomes with LLMs. And the authors use this counterfactual reasoning benchmark class, and they compared the accuracy that GPT-4 achieved with human annotators, and they saw that GPT-4 is getting closer, and GPTs are getting
Are
closer.
they authors from Microsoft? Are they authors from Microsoft?
The first one is from Microsoft. I don't remember the rest. I think at this one more is from Microsoft. Yeah, so we discussed this necessary and sufficient causes. So we can skip this one. And here we have two benchmarks. The first one uses, the first one is from a paper that's providing a data set that LLMs have. Also, the authors provide a novel benchmark, novel data set, and they test the LLMs to see what accuracy they can give us. So the first one, LLMs already know about, but the second one, the authors are giving it to the LLM had not seen before. And when they look at the results on this novel data, they see that GPT-4 can go up to 92% accuracy on the necessary part and on sufficient part, it's and 78%. So it's a big improvement over GPT 3.5. Yeah, this just summarizes what I just said. In the paper, there is another experiment similar to this, where GPT-4 achieved 70% accuracy. And we can move to the discussion. So, what's actually new with Causality now, thanks to LLMs? LLMs provide domain knowledge that used to be only available by human experts. So today, anybody can just be curious about anything and ask an LLM and get an opinion that's often exactly an opinion that a human expert would give. And they can, gather all the knowledge about whatever they're curious about, develop whatever projects without going to school and getting a degree for it. Also, there's a new capability to accept key primitives of text-based reasoning, necessity sufficiency normality that we saw in previous slides. And we can actually analyze actual causality for practical scenarios. Everything is changing when it comes to causality. For example, we need good documentation. We need to verify our analyses with human experts, especially for high risk and high value tasks. So if my abstract graph method doesn't work, that's fine. But if you use too much LLM when dealing with, let's say a psychology has a heavy case and the patient is very sensitive to what the psychologist says, then the psychologist shouldn't just ask everything to the LLM and trust that blindly. Of course, in this case, he should trust his own domain expertise first. There are some high-risk cases like this where we cannot put too much trust in LLMs. And we must ensure correctness for decision making. We basically summarize what we talked about during this presentation in this graph. We first gather our data and we put our main knowledge and what we get from LLM together to identify our question, our research question, which is in this case a causal question, and we estimate it and then we validate it using the help from LLM. Here, thanks to LLMs, projects that deal with causality end to end. Like that's what I'm doing right now too. When I have a big complicated question, sometimes I ask an LLM that's specified for advanced reasoning, and often I see that it can give me an answer that I couldn't have come up with on my own so fast.
Yeah, there is a talk happening right now about how to make a perfect post. Yeah. And Marie is giving it, so I recommend everyone here to go there.
What room is it?
Okay. Okay, I think we are over time anyway. So, I assume you don't have time for questions.
I think.
Yeah.
Okay, thank you.
Yeah, thanks. That's fantastic discussion, fantastic provoking talk.